Tonight, we are very honored. As always, we've had Dr. Eisner here as a frequent speaker. He's a frequent speaker for our chapter in the past, and he's very, very well known. I'm sure a lot of you are aware of his credentials and stuff. He's a man whose career is broad, and his experience covers the whole spectrum from industry to academia. He began his career as a working engineer, moved on to management, eventually holding executive and presidential positions at some high-tech companies. Beyond his commercial exposure, he's been a professor of engineering management and distinguished research professor at the George Washington University. He has taught courses in systems engineering, technical enterprises, project management, information theory. Since 2013, he's served as professor emeritus at George Washington University. He's also a life fellow of both Incose and IEEE professional associations. He's written many books relating to engineering management systems and, of course, systems engineering. Tonight's lecture is based on his latest title, and like I said, the book that will be used as the door prize. So with all of that, I'm now going to turn this presentation over to our speaker, literal legend in the profession of systems engineering, Dr. Howard Eisner.
Okay, I've basically, I'm back with the chapter. Very pleased to be here. I have another book that's coming out in a couple of months, so I'll alert you to that and see if you want to go down that road a little bit. In any case, the topic of this evening is cost effectiveness analysis, which is a rich topic that goes back quite a few years. It seems not to be highlighted by Incose as something important in certification or anything like that. But I think it's an important topic, and I'll try to explain why. Yeah, that's fine. It goes back to the days of McNamara in the Office of Secretary of Defense. And so what we're talking about is something like 1981 or two. They had an Assistant Secretary of Defense by the name of Alan Enthoven. And he subscribed to this approach. And the way the DoD posed the problem is that when we have choices to make about various systems, we approach it through a thing that we have figured out how to do, which is cost effectiveness analysis. Okay, so we'll go on to the next slide, please. Okay, so I'm trying to put forth essentially the method of doing cost effectiveness analysis. And as you might expect, to be simplistic about it, you look at the costs, you look at the effectiveness, and you put those two together somehow or other, and decide what system is superior from a cost effectiveness point of view. There have been places in the DoD, I think in a couple of standards that go way back, where they say what we're interested in, the Department of Defense, is finding or building a demonstrably cost-effective system. So we ought to take note of that and say, okay, how do we go about doing that? Okay, so I mentioned the simplistic approach is simply to say, well, what are the costs? And what are the measures of effectiveness? And crunch those two together and come to some conclusion. Here's a sampling of what we mean by measures of effectiveness for a communication system, generalized, speed of service, grade of service, et cetera, et cetera. If you go to the next slide, we have measures of effectiveness for a typical transportation system. And that should come up shortly. There it is. So if you're looking at transportation systems and trying to decide which one is superior for what type of mission, we have passenger capacity, freight capacity, range of the system, trip time, of course, is one of the more important ones. Now, to again be simplistic about the use of this and maybe something that applies to your life immediately. Let's suppose you're planning a trip and you want to go to, say, New York City from where we are. What approach would you take? Well, the cost effectiveness approach would be basically to say, okay, how do I get there? What kind of mode do I get there? Do I drive? Or do I take the train? I'm going to do a cost effectiveness analysis of that, which is going to tell me roughly what the most cost effective solution is for me, which might not be the same as a cost effective system for you. So let's move on to the next slide. Okay, now if you step back a little bit and you look at the ensemble of systems that have been developed over the years, you basically are seeing three regions. One is the linear region of low cost and low effectiveness. The second is there's a region where the curve starts to tip over, and that's the knee of what I'm calling the knee of the curve solution. And finally, you have the high cost, high effectiveness system. Now, just to comment on it, if you're building a system and you don't have much money, generally you'll select the low cost, low effectiveness system simply because you don't have the money to do any otherwise. A good solution, if you can find it, is so-called knee of the curve solution, which would be where the curve tips over, and you get less effectiveness per unit of cost, so to speak. And then finally, on the high cost, high effectiveness solution, we would have to look at military systems to see quite a few of those. In other words, if we're going to build a weapon or a plane or something like that on the military side, if you're a military person or you're the builder of the system, you will very likely select the high cost, high effectiveness system. The reason for that is that if you're going to go into battle and build a system, which is a military one, you don't want to go into battle with a system that's less effective than your potential adversary. So that's a little bit of commentary on this ensemble of systems. Again, this is kind of a picture of maybe hundreds of systems, and you look at their cost and effectiveness and you put them on a curve, and this is what you get. You get a curve that has a demonstrable tipping point, as well as a high cost, high effectiveness part of that curve. Okay, now the reason why I introduced that is that it's going to play an important part in the final selection and the final use of cost effectiveness analysis. Okay, next slide, please. Now, this is the key to the entire process. It's a little bit hard to read, but I think I can get across the point. You construct a chart which looks like this. And on the left-hand side, it has a series of functions and sub-functions for the system in question. So this method is based upon the first step essentially being to do a functional decomposition in the domain that you're building the system, or a functional decomposition of the system itself. That's I'm not sure that's stressed in the Incose approach. It seems not to be, but I think that functional decomposition is one of the really important parts of system design and system architecting. So let me continue to go over this chart. On the left-hand side, you see a thing that says functions and subfunctions. Now, the system in question that I'm attempting to illustrate is an anemometry system. And you can see under atmospheric sensing, which is a major function of the system, it has wind sensing, wind speed sensing, wind direction sensing, and pressure sensing. So those are the three major sub-functions that this system is supposed to satisfy. Now, if you go to the right, what you see are three alternatives. And they're called alternatives A, B, and C. And then for each one of the sub-functions, you have to come up with how are we going to design to achieve satisfaction in that domain, in that subsystem. So for wind speed and wind speed sensing, we elect to use a pitot tube for alternative A. Then we go to the right and we say, well, what for alternative B, we're going to improve upon that. So we're going to have a pitot tube plus a transducer. And then under alternative C, we're going to have the pitot tube plus a radio transducer. Then we go to the next subfunction, which is wind direction sensing. And for that, we're going to use the shaft position of the anemometer itself. And we have only one solution for that. So it's going to be what we're going to use for all three alternatives. And then pressure sensing, we use the same approach as we do for this wind speed sensing. Then we go to the next function, which is mechanical service. And we do exactly the same kind of thing. For each one of the subfunctions, we conceive of and select, if you will, an approach, design alternative for that. So what we're doing is for each subfunction, very carefully calling out and designing an alternative for that subfunction. We keep doing this for all the functions and subfunctions, and this is the starting point, basically, for architecting the system. So that's why I said this is a systems engineering approach, because we are one and the same, attempting to architect the system with this approach. Okay, you may have seen it before, you may have not seen it before, but it is exactly the approach I would recommend for architecting a system, as well as performing a cost effectiveness analysis. So what we have here is our three approaches, specifically A, B, and C, to the functional needs of the system itself. Okay, we'll go to the next slide, please. Now, the question becomes, where do we go from here? And the next step I'm calling a formal evaluation process. We're assessing the effectiveness with a very specific evaluation criteria for our approach. Now, the evaluation criteria are my approach and my approach only, and everybody will select their own evaluation criteria. What I've selected are the 5 criteria listed performance of the system, human factors related to the system, reliability, maintainability, and risk. So what we're going to do is obtain effectiveness scores by the weighting and rating of some of the criteria that we've selected. So this is a top level approach to cost effectiveness analysis. So let me go and carry out the evaluation. Again, using this simple illustrative case, and it is only illustrative. So if we can go to the next slide, we take each system that we've come up with, and the low cost, the knee of the curve, and the high effectiveness, and evaluate them. These are the three systems, A, B, and C, according to the evaluation criteria on the left side: performance, human factors, reliability, and maintainability, and risk. Now, let me continue to just point out that this is a subjective analysis, but basically addresses the functional areas of the system and also the effectiveness measures. So we talk about satisfying stakeholders, for example, and that's reflected in the notion that each of the evaluation criteria has a weight. You can see the column that says weights, and we have 30% for performance, 20% for human factors, 15, 20, and 15. So the idea behind this is to incorporate the values of the evaluators in terms of what are their criteria and how do we weight them. So we have this little process here whereby it's called the weighting and rating system. And we do precisely that. We rate them, each of the alternatives, and we use the weights that are given for the evaluation criteria and come up with measures of effectiveness for the three alternatives. Okay, so what we're saying is the first measure, top level score is 7.1. And then for the second alternative, we have 7.85. And for the third one, I can't see it because there's something in front of my screen. But I've got a hard copy here, which I can look at very quickly.
I think it says 8.8.
8.8 is the number there. So what we're doing is we're coming up with measures of effectiveness, and that's the critical part of the whole process. And we're using the evaluation criteria that reflect what the stakeholders think about what do I want in my system. And that has often in the past been a point of contention where those are not taken into account. But in this particular way, in the cost effectiveness approach here, we take those into account very specifically and very numerically. Now, the perpetrator of this particular process is now in a position to say, System A, which is the low cost, low effectiveness alternative, has an overall effectiveness of 7.1, and the others are 7.85 and 8.8. Now, then we attempt to find out what the costs are going to be for the system in question, which is an anemometry system. And we have 1.2 million, 1.4 million, and then the number that I can't see,
1.8.
1.8 million. So now we're in a position to stare at that for a while and say, well, which system is most cost effective? One way to stare at them is to divide one by the other. The other is to say how much am I willing to spend, and or which system performs has the best overall effectiveness. So we stare at the high effectiveness system, and that's got the highest measure of effectiveness. And we note that it's 8.8 million. And I asked myself, do I have the money in my budget to get that one? Because that's the most effective system in question. But I have three alternatives, you'll note. You might say, do we need three alternatives? So there's some discussion to be had about that. Now, if you think in terms of the jobs that are done in the Office of the Secretary of Defense, generally they have very important and high-level alternatives to consider, and they have an enormous amount of data on these measures. And they also spend a lot of time doing the cost analysis for them. And generally, I say the answer lies in the knee of the curve solution, because there you're getting hopefully the best, still getting the best performance or effectiveness for the minimum amount of cost. Now, I'm using the words best and minimum, recognizing that we are constructing a subjective analysis of these three alternatives. And I would recommend that we always consider three alternatives and go down that road. Now, that's an interesting point, because you might ask, well, why three alternatives? The reason basically is that you get more information and more alternatives, a broader range of consideration as a systems engineer. The other reason is that there's a thing that floating around the Department of Defense, which is called the AOA. And AOA stands for Analysis of Alternatives. If you dig into that literature and ask yourself, what's the Department of Defense asking for, they always say three alternatives. So basically, using that logic or source, we make sure to get to three alternatives if at all possible. Now, if you're only dealing with two alternatives and you can't think of a third one, then okay, go down that road. Now, I go to the next slide, please. So what we've done is a formal analysis of the effectiveness, and then we approach the cost issue, the cost of the system in question. We take a life cycle cost model approach, which basically says there are three categories of cost and 20 years of cost. So that's a matrix, if you will, where the rows are the RD&T, procurement, and O&M. And the columns are years 1 through 20. So that's the enumerative assessment of costs. And you guys quite a lot of work trying to get the costs, for example, of maintenance in year 19, as an example. But so that's an overall look at a simplistic life cycle cost model. And those are the three categories that one would use in such a model. So in order to generate some of these cost numbers, we go to a thing known as CER, cost estimating relationships. And there's a lot of people working on CERs and make that their career. So we have to go to them. And one of the more important folks doing CER development is a fellow named Barry Baim, who wrote 2 books called Kokomo 1 and Kokomo 2. And he's got a definitive model for estimating the software costs of a system, which are often very difficult for most people to come to terms with. But Barry Baim has done exactly that. An outstanding job of CER development in Kokomo 1 and 2. So I would recommend going with Barry on the software costs if you're going to do this type of cost effectiveness evaluation. So thank you. Next slide, please. So we've covered the cost side, we've covered the effectiveness side, and we've looked at the combination of the two. And we're trying to make a selection, of course, as to which system we're going to build or purchase, for that matter. Now, another look at how to do cost effectiveness analysis is just a rather simplistic approach, but it tells the story. We have essentially 1, 2, 3, 4, 5, 6 alternatives in this case. We're going to purchase a CD player, and the original CD player is we find is going to cost us $27. Then we add functionality to it. So we want to get one that has not only the CD capability, but AM/FM radio. Then we continue to improve that and add a cassette tape function, and improve that by having the CDs be capable of playing 5 CDs on a swivel. And finally, the most capable is adding remote and an iPod interface. So we see, again, in a very simple way, a basic idea. This is a case where you're increasing the functionality, so to speak, in the system where you're considering. I'm using a day-to-day sample example here. That makes it, I think, a little bit easier to recommend and easier to understand. So here's a case where we have variable functionality and variable cost, of course. And then we'll ask ourselves, which one would I buy? Well, you might say, I think I'm okay with just going to the one with the radio, the cassette, and the 5 CD changer. So do I have $40? I have $40. I go with that. Or if you're just saying, all I want to play is CDs, one at a time, put them in there, play the CD, and we're done. Then I have to shell out $27. Which one would you buy? Well, that's up to you. That's up to the user and the purchaser as to what function do you need or want, and what would you be willing to spend for it. So again, this is my way of explaining in a simple way one aspect of doing cost effectiveness analysis. Okay, if you would, you can go to the next slide. Okay, now if you have a very complicated system and you're trying to make a case for one or the other of the alternatives, I would recommend going along with what is represented in the literature as a business case assessment. And in that, you would use the cover the topics that are here for each of the alternatives. Assumptions, the costs, the benefits, and the cash flow and the risk would complete the business assessment. So I think that's the last of my slides. And hopefully this is a top level understanding of what we mean by cost effectiveness. And what we accept is the notion that we're able to identify measures of effectiveness, and we're also able to identify in more precise terms the functions and sub-functions that the system in question is supposed to execute. So thank you for your time, and I'll see you in a while for the next book.
Thank you, Howard.
You're welcome.
Yeah. Is there any questions from the group on tonight's presentation? Anyone?
Yeah, I'll ask a quick question. In the beginning, you mentioned, let's say, you had a communication system, and you listed about 10 different items.
Yeah.
Criteria, I guess, or measures of effectiveness, as you call them, I guess was the ones you were looking for. But then when you one gave your example, you chose maybe 5 for the anemometer, or what? Well, the transducer there for the aircraft. Now, might you have like 10 or so different measures of effectiveness, and then try to weight each one? I guess I'm just trying to think that you might have a pile of stakeholders, say 4 or 5 people, all arm wrestling over which is more important, as a percentage to use, and then actually you maybe do like a sit down and maybe, I don't know, average out the values from each stakeholder. It's like that old drawing we see of the airplane, propulsion group wants the there's huge engines, and yet the aerodynamics guy looks like a glider, and you're talking about the people that do the landing gear, and it's huge, could land a house or something. Well, actually probably do way more in a house. Well, anyway, so you have those items that would it behoove you at the beginning of the process to, instead of myself say choosing which ones I think are important, actually use all the stakeholders and try to rank them and then get the percentages, so that way it is something that's truly more more meaningful, I guess, say it that way. Is that a recommended process for that?
Yes, thank you for that question. It turns out that some while ago I was consulting for a group called the Aviation Advisory Commission, and we went through a formal process. There were 9 commissioners. We went through a formal process of asking each one of the commissioners how they weighted the criteria, and documented that, averaged it out, and came up with the answer for 9 people. So we did exactly that to try to incorporate the various points of view of the evaluators. That's all documented in another book of mine, if you want to track that down. Yeah, it's a good point. Different stakeholders have different views of what they want in a system. And you don't want to just say, well, thank you very much for your information. You want to incorporate it into the evaluation somehow or other. So yes, we do that and have done it as a formal process.
Okay, which book is that? Do you recall which one you had that in?
Yeah, it's called Computer Aided Systems Engineering.
Okay, well, thank
although
you.
I wrote it quite a while ago.
Okay.
That particular point has the numbers in it for the work I did with the Aviation Advisory Commission. Now, if you want to go and check out that particular book, you can basically get it for a very small amount of money. Get a used version and that is in good condition. Maybe cost you $5 for the book.
Oh,
And,
okay. Well, that's very reasonable.
That's about as reasonable as one gets.
Yes, that's very true.
But that
I don't have
book's
to
been-
do a cost benefit analysis on that one for sure, because
Yeah.
that's
Well,
probably
we-
what they call a very
we-
easy choice.
Well, that's what most of us do when we're buying books. We get on the internet and we chase around for a used one in good condition. And usually the numbers can be astonishingly low. So,
Okay. All right.
Looks
Now,
like we
I
have
also had- oh, I was
go
gonna
ahead,
say,
Cass.
Clinton, I had a follow-up. You mentioned in the book that you listed like 4 or 5 different institutions that are teaching courses, and you did mention your alma mater, well, not alma mater maybe, but where you taught at George Washington University, that there was a course. Were you instrumental in crafting that course or even teaching it?
well, about 20 years ago, they asked me to teach a course for a certificate in systems engineering. And I did that, but it got the idea that we can take the certificate and expand it with some courses, and all of a sudden we have a master's degree in systems engineering. This was about 20 years ago that took place, and it turns out I was the one who started the systems engineering master's program at GW. I'm now retired, so the program continues on and has been very successful over the years in both offering directly to students and also offering the masters in a cohort concept, a cohort of people from any particular company, and that's been working for 20 years or so. So yeah, I've been involved directly.
Cool. We have a couple questions in the chat. I'll read it, try and read them to you here. Mike Pafford is asking, can you say a few words about any overlaps between cost-effective analysis and multi-criteria decision analysis?
They're identical.
They're identical. Okay.
Yeah. Multi-criteria decision analysis is what the process we're using for cost effectiveness evaluation.
All right. And then Fidel Isa has a couple questions here. He says, what's the relationship between cost-effective analysis and value engineering?
Well, we'd have to say that it depends on the method one is using in value engineering and how you're computing value. So value is quite different, or can be quite different from effectiveness. So I don't really have a good answer to say precisely what the differences are.
Okay, and then he has sort of a follow-up. I think he goes, do you have any suggested methods for deriving evaluation criteria and weights?
Well, this goes back to the question we were dealing with before. The notion is that we're evaluating alternatives and recognizing that each alternative has a different there's different numbers for the weights for each of the alternatives. Here we're talking about the ones that you saw on those slides as examples. So that's probably all I can say about that.
Right. I was going to follow up. Another fellow has a similar question, Mohammed Alabayari. He says, thank you for the nice insight on the cost effectiveness. He goes, based on your experience, what is best practice to, quote, weigh of the assessment criteria?
Well, I've mentioned I did some work for the Aviation Advisory Commission, and we recognized that there was an issue there. And we put together a formal method of asking each of the commissioners and commissioners that relating to essentially the stakeholders, and asked each of them how they would weight each of the evaluation criteria. And they came up with numbers. Some of them screamed a little bit about it, but basically we all agreed that we were going to make an estimate of the weighting that we saw for each of the alternatives. Now, for example, there was an environmentalist person as a commissioner, and if you stare carefully at his numbers, they turned out the environmental concerns got the highest weight from his point of view. However, other people had different ideas about it. So the notion here is simply to say that we're going to build a little method of getting the weights from a variety of people. It's no more complicated than asking them what their weights are and then averaging all those numbers. So again, that's the answer, or the process we used came up with a matrix and a set of numbers. And if we have a used copy of my old book, it's in that book.
Okay, thank you. Is there
Mhm.
anything else? Any other questions?
I'll say good night, folks.
Good night, Howard.
All right. Thanks, sir.
Good night, Howard. Thank you.
Good night.
I'll be sure to reach out to those ideas to see if we can get some of those speakers from, say, NASA or the fellows.
Right.
Yeah.